examinations, we distribute valued scripts, transcripts to the students, among students. Now I want information from any four students. Say A, B, C, D. These the students' name A, B, C, D. They got in three subjects different. Say maths and physics and chemistry marks. I want. I wrote this part. Suppose maths for A 24, physics he got 20, and chemistry 19. And for the students B, he got B student got 18 in mathematics and 12 in physics and 15 in chemistry. Similarly, the student C got secured mathematics in mathematics marks 22 and in physics 21 and in chemistry 14. And lastly, the student D secured in mathematics how many marks? Say 19. Here physics 12. Here chemistry 60. This is the data collected from the four students of three subjects. Okay. These are the numbers. Numbers may be real numbers, integers, whatever may be. What are they in the blackboard? On the blackboard, they are numbers. Just I put brackets, square brackets here. So remember that. What is the shape of this? What is this called? Tell me. What is this? Already you learned in lower classes, 10th class. Already over, taught. Say, okay. It is a matrix. What are they? Matrix. What are the matrix? Say, the numbers, some different numbers, arranged in a array. Array. Arrangement of the numbers is called array. That numbers are in horizontal lines and vertical lines. Numbers are arranged in horizontal lines and vertical lines. This is called matrix. The matrix is nothing but, once again, the matrix is nothing but arrangement of the numbers in a rows and columns. This is the array. This is a arrangement in box type. This is called the matrix. The horizontal lines are called the rows, and the vertical lines are called columns. Suppose what is this is first row or one, say row 1. This is second row. This is R2. This is third row. This is R3. This is R3. Like that, the vertical lines called the columns. The vertical lines are called the columns. Say C1. Either C1 is the first column and C2. This is the second column. This is the third column. How many rows and how many columns are there? There are 3 rows and 3 columns. 3 rows and 3 columns. Now, alright, this is, take another example. Two, 3, 4, 7, 8, 4. This is also a matrix. This is also a matrix. Here, what are the rows? What are the rows? 1, 2, 3. 3. And how many columns are there? 2. Therefore, I write that 3 by 2. 3 by 2. Generally, speak about it 3 by 2 and write 3 into 2. This shows number of columns and number of columns and number of rows. This is called simply order of the matrix. Order of the matrix. Order of the matrix. This is matrix. This is matrix. So, now in this class, we learn about the matrix, the definition of the matrix, and the types of the matrix, and operations of the matrix, and different properties of the matrix. We learn matrix. Take notes. Matrices. Single form is matrix. M-A-T-R-I-X. Matrix. Plural is matrices. Okay. Matrices. So, write down definition of the matrices. Definition of the matrix. An array of or the arrangement of the numbers in a rectangular form is called the matrix. Write down, or simply the ordered rectangular array. The ordered rectangular array of elements. The numbers is called the elements of the matrix. Array of the elements is called matrix. What is the meaning of the array? Array is nothing but the arrangement. So, matrix, definition of the matrix is an ordered rectangular array of the elements is called the matrix. Say, here we arrange the array of the numbers with these, what are the 9 numbers here? I think this is 4 rows and 3 columns. That is, first of all, write number of rows, that is 4, and next number of columns, that is 3. How many numbers here? There are 4 into 12 numbers, 4 into 3 equal to 12 numbers. The 12 numbers are arranged in here in the form of horizontal lines and vertical lines. Say 4 rows and 3 columns. This is the arrangement of the numbers. This is called matrix. The numbers are called the elements of the matrix. The numbers are called the elements of the matrix. Generally, matrix are denoted capital letters. Say A is equal to, here X is equal to, and so on. B is equal to, and so on. A, B, C. The matrices are denoted by capital letters. A, B, C. The numbers are called elements of the matrix. Suppose if the matrix having generally the matrix A, capital A, having n numbers, m rows and n numbers. That is m rows and n rows, m rows and n columns. This m by n is called the order of the matrix. The order of the matrix is nothing but matrix. The number of rows is equal to m and number of columns is equal to n. Then the order of the matrix is m by n. We call it, but in writing we say m into n. This is order of the matrix. Write down definition of the order of the matrix. The order of the matrix is nothing but number of rows into number of columns. For example, if a number of rows is small m is the number of rows and small n is the number of columns, then we call it m by n is called order of the matrix. Okay. Now the general form of the matrix. The general form of the matrix. The general form of the matrix. The compact form of the matrix is A is equal to Aij into m by n. This is general form of the matrix. We can expand like this. A is equal to another matrix, and another point is the matrices are put in square brackets like this or big brackets like that. So the general form of the matrix is, or the compact form of the matrix is A is equal to Aij into m by n. Here I denotes ith row, the position of the row, and J denotes or represents the position of the column, like that. Here A11, A12, A13, and so on, A1n. So what is here? A11, A suffix 11 is denotes first row and first column. First row and first column. A12 denotes the element in the position first row and second column. A13 first row, third column, like that. Lastly, how many columns are there? N. So A1n represents first row and nth column, like that. So we finish, right? A21, A22, A23, and A2n. A21 represents or tells us the position of the element second row and first column. A22 second row and second column. A23 second row and third column, like that. A2 second row and nth column, and so on. Last in the nth column, how many rows here? Rows are m, small m. So mth row, AM1, first column, AM1 represents the position of the element mth row and first column. AM2 mth column, second column, and so on. Last element is mth column, mth row, and AMN. Nth row, AMN. this position of the element is, what is the position of the element of Mn? Mth row and nth column. So here number of rows, how many rows are there? M. Number of columns, N. So here the order of the matrix is A, or the matrix A is M by N. So general representation A is equal to Aij. Ij indicates running from 1 to N, running from I running from 1 to I running from 1, 2, 3, 4 up to M. J running from number of columns 1, 2, 3, N. This is the general form of the matrix. Okay. So we finished here with the definition of the matrix and order of the matrix. And next, types of the matrix. Types of the, how many types of the matrix? Types of the matrix. One, square matrix. Square matrix. In a matrix, if a number of rows and the columns are equal, then it is called a square matrix. In a matrix, if the number of rows and the columns are equal, then it is called square matrix. Write down a matrix, or in a matrix, if the number of rows and columns are equal, then it is called as a square matrix. Here, say M is equal to N, number of rows is equal to number of columns. So, tell me one example. Example is 4, 1, 3, 2, 0, 7, 5, 6, 9. Here, how many rows? 1, 2, R2 and R3. Here 3 by 3. What is 3? Like that C1, column 1, column 2, column 3. How many columns are there? 3. So 3 rows and 3 columns. This is called a square matrix. This is called square matrix. Okay? And the next one is principal diagonal. Take this example only. Principal diagonal. Next one is principal diagonal. In a square matrix, take example square matrix. Repeat this example. In a square matrix, having principal diagonal. In a square matrix, the elements in the principal diagonal. Say 4, 0, 9. What is this? 4 is the position. What is the position of the matrix? 1, 1, 1. This is 1 2. This is 1 3. This is 2 1. This is 2 2. This is 2 3. This is 3 1. This is 3 2. This is 3 2. Here 1 1. 2 2. 3 3. Here simply I equal j in a is equal to aij m by n. If I is equal to j, the elements with I is equal to j are called the principal diagonal. What is the 4 1 1? That means first row and first column. 1 is 1 is 1 2 position. First row, second column. 3 1 3 position. First row, third column. Say 2 2 1 2 1 second row, first column. And 2 2 second row, second column. 2 3 second row, third column. And 3 1. This is row 3 and column 1 3 2 6 3 2. The element of the 6th position is 3 2. Third row and the second column. What is the position of the element 9? 3 3. 3 3 is third row and third column. In a square matrix, the elements with A11, A22, A33, A44 called the principal diagonal. Called the principal diagonal. Or called the principal diagonal. Okay. Principal diagonal, write down in a square matrix. The elements with I is equal to j. The elements that is A11, A22, A33 called the principal diagonal. And next definition is trace of the matrix. Next definition, trace of the matrix. Suppose A is equal to 4 1 3 2 0 7 5 6 9. Trace of the matrix. If A is a matrix, then trace of matrix A, trace of the matrix A, written as TRA, capital M, TRA. That means trace of the matrix. In a square matrix A, the trace of the matrix is sum of the elements of the principal diagonal. What are the elements in the principal diagonal? 4, 0, 9. So, the trace of the A is 4 plus 0 plus 9 is equal to 13. So, the trace of the given matrix is 13. 4 plus 0 plus 9. This is the square of, this is a trace of the matrix. Okay. Diagonal matrix. Diagonal matrix. Take an example. A is equal to 11, 2, 3. In the matrix A, what are the diagonal matrix? The diagonal matrix is the elements in the principal diagonal, that is position 1, 1, 2, 2, 3, 3. This is the principal diagonal. This is the principal diagonal. This is called the diagonal elements. The others are, otherwise the elements are non-diagonal. So in a square matrix, the non-diagonal matrices are equal to 0 and the diagonal matrices are non-zero. If each non-diagonal elements in a square matrix A is equal to 0, then it is called the diagonal matrix. Okay. Take this example, 11, 4, 7 are the diagonal elements. If this is called the diagonal, principal diagonal, the elements are the diagonal elements. The other elements are the non-diagonal. So this is a diagonal matrix. And the next, scalar matrix. Next, scalar matrix. Scalar matrix. In a square matrix, suppose, or in a diagonal matrix, in a square matrix, the diagonal matrix are equal to same, and the non-diagonal matrix to 0, then it is called the scalar matrix. That means simply in diagonal matrix, you know about diagonal matrix. And diagonal matrix, if the diagonal elements are the each equal. So write down A is equal to 3, 0, 0, 0, 3, 0, 0, 0, 3. Here the diagonal elements are same or all equal, 3, 3, 3. Non-diagonal matrix equal to 0, then it is called the scalar matrix. This is called the scalar matrix. Next, unity matrix. Unity matrix. So, for every definition of the matrix, different types of matrix, first of all, we take unity matrix, square matrix only. In a square matrix, definition of the unit matrix is, in a square matrix, with the principal diagonal elements are equal to 1 and the non-diagonal matrix equal to 0. Say A is equal to and this is a square matrix. This is also square matrix. This is called the unit matrix or identity matrix. The unit matrix or identity matrix. Write down the definition of the unit matrix. In a square matrix, the diagonal elements are equal to each element of the diagonal element is each diagonal element is equal to 1, and the non-diagonal matrices are equal to 0, then it is called the unit matrix. This is also called as unity matrix, identity matrix, and this is denoted by I2. Here I2 means 2 by 2 square matrix. I3 3 by 3 square matrix. I4 4 by 4 square matrix. What is it? In the principal diagonal elements are equal, then it is called the unit matrix. Then it is called the unit matrix. And next one is zero matrix. Zero or null matrix. Null or zero matrix. In any matrix, all the elements are equal to 0, and it is called the zero matrix or null matrix. Say, and it is denoted by O. Suppose 0, 0, 0. This is 2 by 2 matrix, 0, 0. And 0, 0, 0, 0, 0, 0. This is, what is order here? What is order here? 2 by 3. This is 2 by 2, O 2 by 2, and O 2 by 3. These are called the O 3 by 3. 3 rows and 3 columns. All elements are equal to 0. This is called null matrix. This is called null matrix. Next, row matrix or column matrix. Row matrix or column matrix. Suppose take only one row. 2, 1, 7. How many rows? Only one. And 3 columns. B. This is 1 by. Row matrix is 1 by n. 1 by n. This is called the row matrix. What is column matrix? Take definition of the row matrix. In a matrix having only one row, that is called the row matrix. And definition of the column matrix is, if a matrix having only one column, then it is called the column matrix. Like that, X is equal to only one column. 9, 8, 7. This is one column. 3 rows and 1 column. On Y, this is 4 rows and 1 column. This is row matrix and this is column matrix. And next one is triangular matrix. Triangular matrix are two types, one upper triangular and a lower triangular. Suppose in a square matrix, in a triangular matrix are two types, upper triangular and lower triangular. A square matrix A, in a square matrix, Aij is called upper triangular matrix. Upper triangular matrix, if A is equal to 0, if I greater than J, I greater than J, say example, A is equal to, first one we take about upper triangular matrix, 3, 4, 0, 5, 1, 0, 0, 9. What is the condition for the upper triangular matrix? I greater than J. So, I greater than J. Ij represents, I is for row, position of the row, and J is the position of the column. Say this is 1, 1, this is 1, 2, this is 1, 3, this is 2, 1, this is 2, 2, this is 2, 3, this is 3, 1, this is 3, 2, this is 3, 3, 3. So, in our definition of the upper triangular matrix, A is equal to 0 if J greater than I greater than J. Say, what is this? 0, 2, 1. 2, here 2 greater than 1. Take this, 3 greater than 1. Take this, 3 greater than 2. Here I greater than J. This is called upper triangular matrix. Upper triangular matrix. And next one is lower triangular matrix. Lower triangular matrix. So, if A is equal to Aij, matrix in matrix A is equal to Aij, Ij is equal to 0 if I less than J or J greater than I. Write lower triangular matrix. Tell me an example for lower triangular matrix. Here 4, 0, 0, 1, 2, 0, and 9, 8, 5. What is it? J greater than I or I less than j. What is the elements position here? 1 1, 1 2, 1 3. This is 2 1. This is 2 2. This is 2 3. This is 3 1. This is 3 2. 3 3. 3 3. Take this. What is the position of the 0? 1 2. That is j greater than I or I less than j. 1 3 also 1 less than 3. Here also 2 3. 2 less than 3. So in a triangular matrix, this is two types of triangular matrices there. One is upper triangular matrix. In a matrix, A is a small a is equal to 0 if I greater than j. This is called the upper triangular matrix. Example of upper triangular matrix is 3 4 0 0 5 1 and 0 0 9. This is upper triangular matrix. Okay. And next, second one is lower triangular matrix. Lower triangular matrix is nothing but in a matrix, capital A is equal to Aij. Aij represents the element. Small aij represents the element. Ij represents the shows the ith row and jth column. What is the position in row and column respectively? Then if A is equal to 0, if with I greater than j is called the upper triangular matrix. And lower triangular matrix in the matrix A is equal to Aij. Suppose A is equal to 0 if I less than j or j greater than whatever it may be, greater than I. This is called lower triangular matrix. Okay, next one is
we will get so much of loss of disaster. At the time of disasters,
equality of the matrix. Next one is
so much of loss or damage. ఎన్ని రకాలుగా ఉంటుంది
equal to the matrix. Equal to the matrix.
loss of life, loss of property,
Equal to the matrix.
destruction of industry,
First of all, take example.
and also destruction of the
Take
facility. So all
A is equal to A11, A12, A13, A14, A21, A22, A23, A24. This is matrix A. On matrix B is B11, B12, B13, B14, and B21, and B22, B23, B24. Take these two matrices, A and B. A and B. The matrix A and B, capital A and capital B, are with the same order and the corresponding elements are the same. That is, here the order of the matrix is, what is 2 by 4? And what is the order of the matrix B? 2 by 4. Here the orders are same, and also next one is the corresponding elements are equal, same, that is equal. That is A11 is equal to A12, like that. A12 is equal to B12 and A13 is equal to B3 and A14 is equal to B14 and A21 is equal to AB21 and A22 is equal to and B22 and A23 is equal to AB23 and A24 is equal to. So this is called equality matrix. One example is there. Take one example. If A is equal to 1, 0, 9, 4, 5, 8 and B is equal to same 1, 0, 9, 4, 5, 8. These are the odd is 3 by 2 here. This is also 2 by 3 by 2. Corresponding elements are equal. 1, 1, 0, 0, 9, 9, 4, 4, 5, 5 and 8, 8. The corresponding elements are same. Now, take the definition of the equality of a matrix. If matrices A and B having the same order and the corresponding elements of the A and B are same, are equal, is called the equality of the matrices. Example is A is equal to 1, 0, 9, 4, 5, 8 and B is equal to 1, 0, 9, 4, 5, 8. This is called the equality of the matrices. Equal to the matrices. Next.
అడ్మినిస్ట్రేటివ్ రిలేషన్స్ అనేవి ఉపయోగపడుతుంది.
Some of the matrices. Some of the matrices. Suppose A is equal to, take this example, A, matrix A is equal to 5, 1, 7, 8 and 9, 6, 0, 4 and B is equal to 3, 2, 11, 5 and minus 3 and 4. Here 12. So this is 1. So I simply adding these two matrices. Therefore, A plus B is equal to 5, 1, 7, 8, 6, 0, 4 plus 3, 2, 11, 5 minus 3, 4, 11, 1. So 5 plus 3
and also
1 plus 2
industrialization
7 plus 4 7 plus 11 and 8 plus 5 and 9 plus 9 minus plus minus 3 and here 6 plus 2 sorry 6 plus 4 6 plus 4 this is 0 plus 11 this is 4 plus 1 and the others 8 3,
This is known as upright.
20,
So both are
30,
causes to the
6,
disaster.
10, 12,
Both are the
5.
both include human action.
Observe that
Human
the two matrices.
just against
What is the order of the matrix here?
ఈ రెండు
2 by 4. This is also 2 by 4. This is also 2 by 4. What is the resulting matrix A plus B? 2 by 4. So, the sum of the matrices is happen or possible if orders are the same. Orders are the same of two matrices A and B. Here orders is same 2 by 4 and 2 by 4. By adding corresponding elements, you get the resulting matrix A plus B of the same order. What do you observe? What is the observation here? Simply, you add the corresponding elements. Corresponding elements mean the position of the 1 1 element add with 1 1 element. The 1 2 element add with 1 2 element of the other. The 1 3 element, the position of the 1 3 element is add another 1 3 position of the like that 1 4 here 1 4. So we add 3 5 plus 3 1 plus 2 7 plus 11 8 plus 5 like that 9 plus minus 3 6 plus 4 6 plus 4 and 0 plus 12 and 4 plus 1 we get 8 3 18 13 6 10 12 5. What is earlier? Same 2 by 3. So if let write down, let A and B, capitals A and B, be the matrices of the same order, then the sum of the matrix A and B is the sum of the corresponding elements, of the A and B. If the matrix is same order, that means if the matrix is A of order m by n and plus the matrix is B, second matrix is m by n, then the resulting matrix is after getting addition of the corresponding elements of the both A and B, you get A plus B, resulting matrix is A plus B. This is sum of the matrices of the same order m by n. You get the orders are same. Write down. Simple definition. Take this example.
Planning, organizing, coordinating and implementing the policy are
Okay.
very necessary
It's clear.
to reduce the effect of the natural hazards or disasters. And limited to the
By notation, mathematical reduction, we get the sum of the matrices. If matrix A is equal to Aij, this is order m by n, and B is equal to Bij, this is order of the m by n. You get the resulting matrix or sum of the two matrices. Here, sum of the two matrices. Simply,
ముందుగా తెలిసిన సాంకేతిక పరిజ్ఞానం మనకు ఉంది వస్తుంది అని తెలియగానే మనం ఏం చేయవచ్చు సైకిల్ వస్తుందని తెలియగానే
Aij
ఆ నష్టం నుంచి మనం బయటపడడానికి ఏమన్నా
plus Bij, therefore this is Cij, where Ci is nothing but Aij plus Bij. Answer same. M by n, M by n, M by n. Okay. It is sum of the two matrices. Okay. Next class we discussed about the properties of the matrices. Properties of the matrix. Like operations of the matrix in additive on addition and also multiplication. Okay. Thank you very much.
Line spectrum of hydrogen. Line spectrum of hydrogen. Okay. Line spectrum of hydrogen. Balmer is the first scientist. He did the experiment by using hydrogen gaseous atoms. Okay. In 1885, Balmer did an experiment by passing electromagnetic radiation on hydrogen containing hydrogen atoms containing sample. He did an experiment by passing electromagnetic radiation onto the sample. Sample contain gaseous hydrogen atoms. Gaseous hydrogen atoms. Okay. He passed the electromagnetic radiation. Mainly it contains white light. Various electromagnetic radiations. UV radiation is also electromagnetic radiation, IR radiation is also electromagnetic radiation, and visible radiation is also electromagnetic radiation. He takes only white light. It means visible radiation. In electromagnetic radiation, he preferred white light is passed into the sample. Okay, he passed the electromagnetic radiation. Electromagnetic radiation mainly contains white light. Okay, in electromagnetic radiation, he takes white light. Okay. Remaining part he did not do the experiment with the remaining electromagnetic radiation. He only preferred white light or visible radiation range. He only preferred that range. He passed visible radiation only. So the remaining parts UV, IR radiations are also electromagnetic radiation. With that radiations, some of the other scientists do the experiments laterally. The first is the Balmer is the one person in 1885 he did the experiment by passing white light into the hydrogen atom. The sample contains the hydrogen atoms. Okay, white light is also belongs to electromagnetic radiation. That is the reason why you call it as electromagnetic radiation is passed into the sample. And he observed absorption spectra and emission spectra. Okay, then he observed absorption spectra and emission spectra. Okay, whenever he passed the white light into the hydrogen atoms sample containing hydrogen atom containing sample, he observed absorption spectra and emission spectra. Okay, how then he can explain the absorption spectra and emission spectra with respect to the equation given by the Rydberg. Rydberg is the scientist. He has given the one equation. Wave number is equal to 109,677 into 1 by n1 square minus 1 by n2 square. Okay, square bracket centimeter inverse. Okay, using that equation he can explain the his experiment based on that equation based on that one. Okay, absorption spectra, AB, absorption and emission spectrum. Emission spectra. Okay. He observed by passing white light in this electromagnetic radiation, he can observe absorption spectra and emission spectra. Okay. It can give absorption spectra, bright line absorption spectra contains dark lines, okay, dark lines which we are discussed in previous class. Okay, emission spectra gives bright lines, BRIGHT, bright lines. Okay, we know. Whenever we pass into this one, okay, initially we can get absorption spectra, and then laterally atoms absorb the radiation, then we can get the absorption spectra. Whenever atom goes to higher energy state, it is unstable, then electron come back to the ground state, then it can give the emission spectra. That is the reason why you can observe two types of spectrums. Okay, two types of spectra, absorption spectra and emission spectra for line spectra of hydrogen atom. Balmer did this experiment. Okay, he explained his spectral lines by passing white light into hydrogen atom. You should explain these two concepts by taking the one law. This is 109,677 1 by n1 square by 1 n2 square. This is introduced by Rydberg. This is the scientist name is Rydberg, R-Y-D-B-E-R-G, Rydberg. Okay, Rydberg has proposed this equation. Rydberg has given this equation. So the scientist name is Rydberg. The constant is Rydberg constant. Rydberg's constant. Okay, this is known as Rydberg's constant. Okay, Rydberg has given this formula. On experimental data, Balmer, he was explained his experiment, these lines by using this formula. By using his formula, okay, he can explain his experiment. Okay, Balmer has did this experiment, he get the dark lines and bright lines. Okay, then he will take his formula for the explanation of his experiment. Okay, then he explained his experiment by taking this formula. Okay, like this. Wave number, nu bar means wave number, which is indicated as 1 by lambda. 1 by lambda, okay, is equal to wave number. This is known as wave number. Nu bar is known as wave number. Wave number means 1 by lambda. Okay, nu bar is equal to 109,677 1 by 2 square by n2 square. He can explain these two experimental data by using this formula. Okay, Balmer is the first scientist. He can explain his practical by borrowing this formula like this. Okay, from this we understand how do we understand the Balmer lines is, okay, Let us understand these Balmer lines. Okay, whenever electron goes to okay, n1 is equal to 2, n2 is equal to higher numbers 3, 4, 5 and so on. Okay, whenever electron goes to n1 is equal to 2, n2 is equal to 3, then there is a absorption of radiation takes place. So there is a absorption. Okay, then it is also, you may write like this, n2 is equal to 4. This is also Balmer series, which is also in Balmer series. Balmer explained that in this experiment he observed whenever white light is passed into the sample, it can give the two types of lines. Okay, these lines as explained as initial stage is 2, the final destination is, it may be 3, it may be 4, okay, final destination it may be 5 and so on, 6, whatever it may be, n is infinity. These lines are belongs to the Balmer series, absorption. These lines belongs to the Balmer series. First he explained. Okay, he is the first scientist. He can explain whenever white light passed into the sample, he can get the two types of lines, dark lines and bright lines. To explain this, he borrowed this principle, this equation from the Rydberg, and he has explained initial stages. Atom has levels, atom has the energy levels. Whenever electron goes to initial stage, start he also observed absorption spectra and emission spectra, same case. And he also explained taking this one into taking 1 to any level, which can give the Lyman series. In absorption, Lyman explained like this, n is equal to 1, 2, 3, 4 and so on. Okay, and initial stage is 1, 1, 1. Okay, final stage is 2, okay, 3, 4, 5. If the electron goes to n1 energy level to n2 is known as Lyman. If electron goes to n1 to n3 is also Lyman, 3 to 4. The starting point is 1, the ending point anything is known as Lyman series. That one is absorption spectra, which we understand that it is absorption spectra for Lyman. Lyman also given the emission spectra. In emission spectra, electron goes to electron comes from the 2 to 1, 3 to 1, 4 to 1, anything comes from any energy level goes to from any energy level to the ground level, any n1 is equal to 1, then that is belongs to the emission spectra of Lyman series. Okay, which is Lyman did the practical by using UV light. By using UV light, he did the same experiment. He can also get the absorption spectra, emission spectra. He can explain absorption spectra from electron from n1 to n2, n1 to n3, n1 to 4. Okay, like this. This is absorption. Electron goes to from 1 to 2, 1 to 3, 1 to 4, 1 to nu wave number is equal to 109,677 into 1 by, okay, n1 is equal to 1, N2 is equal to 2, 3, 4 like this, so on. Okay, he explained this one. Lyman explained the spectral lines by using this formula, by using Rydberg's formula. Okay. Next scientist will come into the force. He also explained this one, that come into Paschen. Next one is Brackett. Next scientist Brackett, and next scientist Fund. Okay, na? Next scientist Fund. These are the scientists. These are the science. 5 number of scientists can explain electromagnetic spectra. Electromagnetic spectra of line spectrum of hydrogen. Line spectrum of hydrogen atom. Okay. You can write down the final picture how you can explain the whole concept. Okay, let us take this one. Lyman, Balmer, Paschen, Brackett, Fund. Okay, he explained the lines. Starting point N1 is equal to 1, 2, N2 is equal to 2, 3, 4 and so on. Next, he is explained to final stage N2 is equal to 3, 4, 5 and so on. Next, Paschen explained N1 is equal to 3, N2 is equal to 4, 5, 6 and so on. Next, Brackett equal to 4, N2 is equal to 5, 6, 7 and so on. Okay, using this methodology, this idea. Next, the region, electromagnetic region. Lyman explained his lines, UV region. UV light, he explained his region, electromagnetic region. EMR region, electromagnetic region. Okay, electromagnetic region, UV. Balmer take visible radiation. Okay, Paschen, IR radiation. Brackett also taken IR. Okay, the remaining scientist explained his practicals by taking these regions. Okay, always Lyman's series explained. Electron goes to N1 to next energy levels 2, 3, 4 and so on. Next, Balmer can explain his series from N1 is equal to 2 to N is equal to N2 is equal to 3, N2 is equal to 4, N2 is equal to 5, so many. Like that. Same way Paschen has explained his lines by taking IR radiation. He passed the IR radiation through the sample, he get the lines. These lines are explained by Paschen like this, taking these numbers. Okay. And another scientist comes into the light. Next, Brackett, he did the same experiment. The previous ones, they did the same. He did the experiment, Brackett, from his idea, N1 is equal to 4 to N is equal to 5, 6, 7. So, he also succeeded by taking IR radiation passed into the sample. Next scientist in Fund, he's come into the light and he gives the he did the experiment by passing the electromagnetic radiation, IR radiation into the sample. Then he get the lines. Okay, he has explained electromagnetic radiation, electromagnetic spectrum. Okay. Okay, these are the radiations they passed into the samples. These are the radiations. The region means Lyman passed the UV radiation, Balmer passed the visible radiation, Paschen passed n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8. The lines are. Okay. Whenever electron comes from second level to one level, and then whenever electron comes from second level to first level, and whenever electron comes from third level to one level, fourth level to one level, okay, next fifth level to one level, okay, sixth level to one level, okay, seventh level to one level. Okay, these are the enough, I think. You may write down another line, eighth line to. These lines are known as Lyman series. Lyman series. Okay, this is mainly observed in emission spectra. Emission spectra. Electron comes from second level to one level, third level to one level, fourth level to one level, any level to number one is known as. It can give the spectrum because of these transitions. Because of these transitions, we can get the spectrum, or that spectrum. The spectrum is Lyman spectrum. Okay, electron comes from second level to one level, third level to one level, fourth level to level. Because of these transitions, okay, which takes place in an atom. Okay, in a different atoms, not in a particular atom. One atom cannot give all the lines. Okay, one particular atom can give these lines, another atom can give this one, another atom, another atom, another atom. Different atoms can give this type of lines. Okay, by passing UV light, you can get these lines. Okay, this is studied by the Lyman. This is known as Lyman lines. Next case, another scientist. This is emission spectra. This is emission spectra. Emission spectra. This is emission spectra. Whenever electron comes from third to second level, and same way, fourth to second, fifth to second. Okay, sixth to second, seventh to second, eighth to second. Okay, any energy levels 2, electron comes from in a particular atom, electron comes from higher energy levels to second level. Okay, you can get some atomic spectra, emission spectra for hydrogen atom. Then these lines are known as Balmer series. Balmer series. These lines are Balmer series. Okay. These lines are Balmer series. These lines are Lyman series. Next scientist we know 4 to 3. Okay. 5 to 3. 6 to 3. Okay, 7 to 3, 8 to 3. These are studied by the Paschen. Okay, Paschen series. Paschen series. Next one is, okay, any level to third level is known as Paschen series. Any level to third level gives the Paschen series. Any level to second level, Balmer series. Any level to first level, Lyman series. Like that you can remember easily. Next, any level to fourth level, any electron comes from any level to fourth level, okay, which can give the spectrum. That is known as any level to 5th to 4, 5, 6 to 4, 7 to 4, 8 to 4. Okay, it can give this spectrum. These spectral lines are known as, okay, Lyman, Balmer, Paschen, bracket. Okay, bracket. Okay. Next one, electron comes from any level to fifth level. Any level to fifth level is known as fund. P-F-U-N-D, fund. Okay, any level, fifth level, 6 to 5th, 7 to 5th, 8 to 5th. 8 to 5th is known as fund. Okay, it is also indicated by fund series. Bracket series, okay, Paschen series, like this you can understand. Emission spectra. Sir, what about the absorption spectra? Okay, did you write the absorption spectra for this hydrogen atom? Okay, you may write it. Okay, easily. Same, reverse it. Reverse the this one, can get the absorption spectra. Reverse this one, when electron goes to an absorption, electron goes to N1 to N2, N, reverse. The arrow mark reverse to this one, you can get the absorption spectra of the line spectrum. You can get the absorption spectra by reversing the same concept into reverse this one. Electron goes to N1 to N2, 1, 2, 3, 1, 2, 5. Okay. Indicate the arrow mark like this, you can get the absorption spectra. Same Lyman, scientist names does not change. Scientist names does not change. You can get the absorption spectra on that way. Okay, this is the this is about the line spectrum of hydrogen atom. It is very important for intermediate public examination, and this is the very important question for the intermediate public examination. Thank you. Welcome to the class. Today topic is photoelectric effect. Okay. Hertz is a scientist, has performed experiment. In this experiment, he has taken some alkali metals, means potassium, rubidium, cesium. Okay, potassium, rubidium, cesium, like the alkali metals. Potassium, rubidium, or cesium. Okay, he has taken the type of metals, and then light is projected on that metal surface. Then he observed some electrons are ejected from the metal surface. So this is known as photoelectric effect. Okay, when light fall on some active metals, not all the metals, these are the active metals, means 1A, alkali metals. So whenever light falls on active metals, okay, it can eject electrons. Okay, he is observed this. This is known as photoelectric effect. Okay, next he was explained this photoelectric effect by taking 3 points. He considered 3 points to explain this photoelectric effect. He was constructed the construction of the diagram is like this. Metal surface, active metal surface, light fall on this metal surface, and electrons are ejected. These ejected electrons are measured by this type of arrangement. Okay, one wire is connected battery like this, and this one is connected back to the battery. This is ammeter. Okay, ammeter. Okay, ammeter. Okay, this is the way he can observe. He can observe active metals eject the electrons whenever light fall on a particular metal. Okay, this is known as photoelectric effect. He has observed the photoelectric effect with this type of arrangement, with this type of practical arrangement. Okay, from this experiment, he was explained this experiment. First point, the electrons are ejected from the clean metal surface as soon as beam of light strike the surface. Okay, as soon as lights strike on the metal surface, okay, simultaneously electrons are ejection takes place. There is no time lag between the striking of the light beam and the ejection of the electrons from the metal surface. Okay, what it indicates, whenever light falls on a certain metal, active metals, okay, simultaneously electrons are ejected from the metal surface. There is no time lag between the light fall on the metal surface and electron ejection. So simultaneously it happens. So it indicates the first point. Next, second point is, okay, second point, the number of electrons ejected proportional to the intensity or brightness of light. Okay, number of electrons are ejected like this is proportional to intensity or brightness of light. If you are projected bright light, okay, it is focused, the metal is focused for bright light, then it can emit okay, more number of electrons than compared to the pale light. Okay, brightness is increases, then number of electrons ejection will be greater. Okay, this is the second point. Okay, bright light will fall on a metal surface, then it can eject more number of electrons than compared to the less brightness light. Okay, less brightness light can eject only a few number of electrons. If more brightness of light projected on the metal surface, it can eject the more number of electrons from the metal surface, which is indicated as the number of electrons ejected is proportional to intensity or brightness of the light. Okay, this is the second point. Okay, next, third point. What focus the third point? What it says? For each metal, there is a characteristic minimum frequency mu naught. Every metal has characteristic minimum frequency. Okay, this is known as threshold frequency. This frequency is known as threshold frequency, below which photoelectric effect is not observed. Okay, below which photoelectric effect is not observed. At a frequency nu greater than the nu naught, the ejected electrons comes out with certain kinetic energy. The kinetic energy of these electrons increases with increased frequency of light used. What is it means? Okay. Okay, let us take an example to understand this concept. For example, take one metal, potassium metal, has certain frequency. Threshold frequency is known as 5.0 into 10 to the power of 14. Okay, 10 to the power of 14 H. Okay, whenever red light is falls on metal surface, okay, electron ejection not takes place because its frequency of red light is 4.3 to 4.6 into 10 to the power of 14 H. Okay, the frequency of light is less than this, so ejection of electron not takes place. When the ejection of electron takes place, the light energy or light frequency should be greater than to the metal which you are taking for the photoelectric effect. So frequency of the light is less than this one, so photoelectric effect is not possible. Okay, when photoelectric effect is possible, is ejection of electrons is possible when the light falls on the metal surface have frequency is greater than the metal frequency. Okay, then only photoelectric effect or ejection of the electrons takes place. Ejection of the electron takes place. So, nu of weak yellow light is 5.1 to 5.2 10 to the power of 14 H. Okay, it means this energy is greater than this one. So, the light energy should be greater than this one. Then only ejection of electron takes place. Then only ejection of electron takes place. If the projected light, when the light is false, that projected light is less energy, the ejection of electrons is not takes place. If it has greater energy, then only ejection of electron takes place. Now there is another question. If the frequency of light, is very high, okay, if it is here, the weak yellow light is 5.1 to 5.2 10 to the power of 14 H. Okay, in case the energy of this one is very high, 6.0 or 10.0 into 10 to the power of 14 H, then what happens? So, then what happens means the energy of projected one, the light energy is very high, the light frequency is very high then compared to required metal frequency, threshold frequency. Then the remaining energy is converted into kinetic energy of the electron. So the gap between these two, the projected light energy, okay, frequency and this frequency, okay, this difference is very large. This one is as very large value. Then that energy is get converted into for the kinetic energy of the ejected electrons. This total energy is converted into electron movements. Okay, then it is converted into kinetic energy of the electrons. So electrons will come out with forcibly, with greater kinetic energy. Okay, the whole energy from this energy minus this energy gives this some certain energy. This energy is utilized for the movement of the electrons. Okay, this is the way they are represented here. The ejected electrons come out with certain kinetic energy. The ejection of electrons come out with certain kinetic energy. The kinetic energies of these electrons increases with increased frequency of light used. Okay, frequency of light. Okay, the ejected electrons come out with certain kinetic energy. Okay, the kinetic energy of these electrons increases with the frequency of light used. If the frequency of light is very high, then the ejected kinetic energy of electron is very high. Okay, if this frequency of light is equal, if these two are equal, then ejection of electron only takes place. The ejection of electron only takes place, but there is no kinetic energy. The movement of electron is slowed down. Okay, there is a reason why the kinetic energy of the ejected electron, the kinetic energy of the ejected electrons is depend on the light frequency. The light frequency is very high, then the kinetic energy is very high. If it is very low, okay, if the kinetic energy of the frequency of light is less than this, okay, if the frequency of light energy is less than this, then ejection of electron is not takes place. Okay, this is the idea they have given. From these 3 points you can understand very easily in photoelectric effect. Next, there is another point. When brightness increases, number of electrons ejection is increases. Okay, brightness increase means number of photons are increases. Brightness increases, number of packets of energy is increases. Number of packets increases, number of electrons ejection is also increases. Okay, brightness of light increases, number of electrons is increases. When frequency of light increases, the kinetic energy of the electrons increases. This is the main 2 points which you can remember always. Okay, brightness increases, number of electrons ejection is more. Okay, because brightness means number of photons are greater. Okay, electromagnetic radiation has particle nature, which indicates it has number of photons. Okay, number of brightness increases, number of photons increases. So number of photons increases in a particular light, then number of electrons ejection is also takes place, is greater. Next point, then the frequency of light increases. The frequency of light increases. Okay, the frequency of light increases. The increased energies get converted into kinetic energy of the electron. Electron movement is fast. Frequency of light increases. The moment of electron is fast, and we can say kinetic energy of the electron is greater. Okay, you can understand this way of the photoelectric effect. Next, there is another question has appeared. Radiation propagates. Whenever electromagnetic radiation propagates, it has wave nature only. So, next, whenever these electromagnetic radiation strikes any surface, okay, whenever this electromagnetic radiation strikes any surface, it has particle nature. Okay, so in this way he can explain dual character of the electromagnetic radiation. Dual character of electromagnetic radiation is explained by the scientist like this. Whenever electromagnetic radiation moves in space or somewhere, it moves. On movement of the electromagnetic radiation, it has the wave nature. Whenever this electromagnetic radiation strike any surface, okay, it behaves as a particle nature. It behaves as a particle nature whenever it can strikes on any surface. So this is the way they can explain dual character of the electromagnetic radiation. Dual character of the electromagnetic radiation says whenever wave can move freely, it has wave nature. Okay, whenever electromagnetic radiation moves freely, it has a wave nature. Whenever it strikes on the metal surface, it behaves as a particle nature. Okay, these are the 2 simple points you can understand. Next, you can also understand one point, that is based on photoelectric effect, they are derived on the equation H mu is equal to H mu naught plus of mv square. Of mv square is equal to, this is known as kinetic energy of the electron. This is known as kinetic energy of the electron. Okay, you may write this equation into H mu is equal to work function plus Ke. Okay. Whenever certain light falls on certain metal surface, this frequency is greater than this frequency, then only ejection of electron takes place. If this frequency is greater than this one, then it is the difference of these 2 energies get converted into kinetic energy. This difference of these 2 energies get converted into kinetic energy. You may write like this: H mu naught is equal to half mv square. Equal to half mv square. This is known as kinetic energy. So the difference of these 2, threshold energy and the frequency of light, okay, these 2 is known as kinetic energy. Okay, they have given kinetic energy like this. Okay, you may write like this: H mu is equal to the W naught is known as work function. It is known as work function plus kinetic energy. Kinetic energy of the electron. When kinetic energy of electron is possible, this frequency, light frequency greater than threshold frequency, then only this remaining energy is get converted into kinetic energy of the electron. Okay, this is the way you can understand the photoelectric effect. Okay, let us focus on a problem, that is the threshold frequency nu naught for metal is this one. Threshold frequency of metal is like this, mu naught. Calculate the kinetic energy of an electron emitted, okay, emitted when radiation of frequency nu is equal to 1.0 into 10 to the power of 15 second inverse hit the metal. Okay. Next, this is nu, this is known as nu naught. What is the means of kinetic energy? Let us use the formula from the photoelectric effect. H nu is equal to h u naught plus kinetic energy. They want, what they require is what is the means of kinetic energy. Calculate the kinetic energy of electron. Okay, then you may write like this, h nu minus h nu naught. This one you can write like this also. H is a constant value. H is always constant, is a Planck constant, 6.626 into 10 to the power of minus 34 joules. Another value difference, nu value is 1.0 into 10 to the power of 15 minus nu naught. They have given nu and nu naught. Nu is equal. Let us see nu and nu naught value. 10.0, 7.0 into 10 to the power of 14. Subtract these two, you can get this one, and multiply these two, you can get the 1.988 into 10 to the power of minus 19. So in this way you can calculate the kinetic energy of the electron from the given data. Okay, so you can understand this way, photoelectric effect.